Power transformers transform electrical energy from one voltage level to another by stepping voltages up for transmission to minimize losses, or down for distribution. They belong to the most valuable assets of a utility. Manufacturing a new transformer and transporting it to site results in substantial costs. However, the damage caused by a transformer failure and the subsequent loss of production may end up costing far more. Utilities therefore try to keep their transformers in operation for as long as possible. During regular operation, and in particular during an electrical fault, power transformers are subject to electrical, mechanical, thermal, and environmental stresses. Power transformers are exposed to mechanical stress during transport from factory to site, during relocation from one substation to another, during earthquakes, or during external short-circuit faults. Transformers have to withstand the stress of operating voltages, as well as pulse voltages like lightning or switching pulses. The inner losses, dominantly caused by load current, must be dissipated. High temperature causes deterioration of the transformer's insulation materials. Transformer failures caused by these stresses can result in explosions, subsequent fire, and costly aftereffects such as long outages caused by cleanup and plant repair, as well as the long delivery times of new transformers. Therefore, utilities and service providers test power transformers in order to assess their condition, schedule maintenance work, and plan the replacement. The most common electrical methods include measuring winding resistance and checking the tap changer, measuring transformer ratio and excitation current, and capacitance and dissipation factor or power factor measurements. Measuring the winding resistance and comparing it to factory measurements allows possible winding damage to be identified. For instance, winding short circuits or contact problems of the windings, leads, or the tap changer. Measuring ratio and magnetization current helps to identify short circuits between winding turns. Capacitance and dissipation factor or power factor measurements are performed to evaluate the condition of the transformer's bushings. After an electrical failure, winding geometry and insulation integrity may also be verified using advanced diagnostic measurements such as short circuit impedance or leakage reactance and frequency response of stray losses, or measuring power factor or dissipation factor over a range of frequencies. Through periodic and diagnostic measurement and maintenance efforts, utilities and service providers help satisfy the ever-growing need for a reliable electrical supply 24/7.